In these videos, I use chemicals that can cause burns and respiratory problems. If you are to replicate any of the experiments or procedures shown in my videos, please do so in a fume hood or outside, and please wear suitable gloves when handling acids. Hello everyone, and welcome to my first ever YouTube video. In this video, I'm going to replicate the first experiment I did in regards to precious metal recovery. This experiment was what got me interested in recovering precious metals from e-waste. I'm going to use the materials I had at hand at the time, as acids are difficult to come by where I'm from. And most acids I have to make myself. I will be making videos on this, so keep an eye out for those. So for this experiment, you are going to need some material to recover gold from. Here I have a small selection of material. I have a couple of processes, and some fingers off some Intel Pentium slot cards. I also have some ribbon cable ends. I've stepped them down to save on reagents. There's also a couple of SIM cards in there, and a few RAM fingers. So for the reaction, you will need some vinegar, also known as acetic acid. And you'll need some table salt, also known as sodium chloride. You will also need some hydrogen peroxide. This can be bought from Amazon or some local pharmacies as a disinfectant. And you'll need some glassware. I'm using an old coffee jar to show it can be done without expensive lab beakers. So, let's get started. First, add your material to the jar. For some reason, I struggled with this and threw them everywhere. Next, add your acetic acid. I'm not measuring it. I'm just pouring enough to cover all of the material. Then add your sodium chloride. Again, I'm not measuring, but I'd say I poured in around 3 tablespoons. Give it a little swirl around to mix them a little. And add your hydrogen peroxide. I actually measured this one. You don't need a lot, just enough to get the reaction started. I poured in 100 milliliters. And add the hydrogen peroxide to the solution. Now it's just a big waiting game. This reaction does take a while, but it does save on expensive acids. So you have to decide which you value more, cost or time. Personally, for such a low amount of material and for the cost it would take to make nitric acid, doing it this way is fine. And I can leave this and come back to it at a later date without worrying about it. I have put the lid on the jar, but it's not on tight. It's just placed on top. This allows any gases to escape. You will notice almost immediately bubbles starting to form inside the solution. So, what exactly is going on in there? If you look at the equation, we are putting in acetic acid, sodium chloride, copper, and hydrogen peroxide. And we are producing copper chloride, sodium acetate, and hydrogen gas. The acetic acid is reacting with the sodium chloride to produce hydrochloric acid and sodium acetate, and the hydrogen peroxide is oxidizing the copper, which in turn reacts with the hydrochloric acid to produce the copper chloride. I'll let this react and go for a cup of tea.
Around 10 minutes later.
Coming back to the reaction, you can see that the color is starting to turn a bluish-green color. This is the copper from underneath the gold foils going into the solution. Eventually, all of the copper will be dissolved, and the gold foils will lift from the circuit boards. It's rather hypnotic watching the gas raise the lighter pieces up in the solution. It reminds me of an old lava lamp. I could sit and watch it for hours. This is going to take a couple of weeks, so I'll put it away for now and come back at a later date. If you are going to try this, please remember to keep it out of the reach of children.
1 week later.
It's been 7 days since I started the reaction, and as you can see, the solution has become a little saturated with copper. A lot of the gold foils have separated from the boards, and I could leave them longer in the solution to slowly etch away the remaining copper. But I want to speed things up a little, so I'm going to add some fresh reagents to finish the job a little quicker. The reagents are really cheap and I'm a little impatient. I'll just decant the solution into this jug and mix a fresh batch. Some of the foils will travel over, so I'll keep it to one side and filter everything together. Let's throw in some fresh reagents. So, in goes the acetic acid. Then the sodium chloride. And finally, add the hydrogen peroxide. After a couple of minutes, the reaction is already underway. I love watching the hydrogen bubbles lifting the gold foils. I'll let this react for a couple more days, and hopefully, it will be ready for filtering.
2 days later.
A couple more days have passed, and it appears that all of the gold foils have lifted from the circuit boards. So the next thing for me to do is get these solutions filtered and collect the foils. I'm going to use this conical flask, but if you don't have one, you can use another coffee jar. Here, I'm using a cotton filter and a funnel to do the filtering. You can use a coffee filter for this or even a lab filter. But I find that the cotton filter allows the solution to pass through much quicker, and it doesn't clog up as easily as a coffee filter. First, I'll decant the solution in the jug. There's some gold foils at the bottom mixed with a white precipitate. This looks to be copper 1 chloride. This can easily be dissolved in a little hydrochloric acid. I'll spray that in last, as I don't want to clog the filter and slow down the filtration. Next, I'll use a kitchen strainer to separate the foils from the circuit boards. This needs to be a plastic strainer. If I were to use a steel one, I would risk plating the copper out of the solution. The next step is the most tedious step. Some of the foils will stick to the circuit boards, so each individual board needs to be checked, and if needed, washed with a spray of water. This can take a while, so I won't bore you with it, and I'll get back to you when it's all done. Here's the majority of the foils. They're around 22 carat, and they look beautiful. Let's get them in the filter.
Nice.
We have now successfully recovered all of the foils. And all it took was a few household ingredients. If you wish, you can melt these as they are. Or alternatively, you can save them until you have more. Personally, I like to give them a quick refine and collect the gold dust, which is what I'll do next. Refining means using a few more serious chemicals, and you will need to heat the solutions. This cannot be done in a jar safely, and you would need heat-resistant glassware.
Refining the gold.
For the refining, I'm going to add around 40 milliliters of hydrochloric acid and set the hot plate to a low heat. Next, I'll add around a quarter of a spoon of potassium nitrate. This will react with the hydrochloric acid to form what is known as poor man's aqua regia. Potassium nitrate will react with hydrochloric acid to release nitric acid, which will give off nitrogen dioxide fumes. This means that this reaction should be performed outside or in a fume hood. Nitrogen dioxide should not be confused with nitrous oxide. They're two completely different things. Inhaled nitrogen dioxide could react with moisture to make nitric acid in your lungs. Aqua regia is used to dissolve gold. Neither nitric acid or hydrochloric acid can do this alone. Nitric acid will act as the oxidizer and is used to form gold ions. The hydrochloric acid is then used to react with the gold ions to form tetrachloroaurate anions. The gold ions can then be removed from the solution, which further allows the oxidation of gold. The gold is then dissolved to form chloroauric acid. This is going to take 5 minutes, so I'll speed it up. If the reaction stops bubbling or stops producing brown fumes, and you still have visible gold, you can add a little more potassium nitrate to get it going again, but be careful not to overdo it. A little goes a long way. After 5 minutes, the reaction is complete. And there are no more bubbles, and there's no more visible gold, so now it's time to get it filtered. This is an important step in the refining. Remember, the cleaner the solution, the cleaner the drop. Be sure to perform a stannous chloride test to ensure that there is gold in the solution, and when it's dropped to ensure you've gotten all of the gold out of the solution. I make my own stannous chloride, and I'll post a video on how to make your own soon. Brown stain for gold. Now the solution is filtered and beautifully clear. I can put in some sodium metabisulfite. This is used to precipitate the gold as a powder. This is the exciting part. As the sulfur dioxide precipitates the gold, it causes the solution to go from yellow to clear, and then brown. It's like magic. I'll let the gold settle overnight, and in the morning, I'll wash it with some water, dry it, and weigh it. I'm not expecting a lot. There wasn't a lot of material to begin with. And there it is, 0.3 grams of 24-karat gold. It's not a lot, but it's better than being thrown away. And if you do this 100 times, you could have an ounce. It was also a lot of fun. Thanks for watching, and I'll see you in the next video.